Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to be going over Lewis symbols and how they can be used to represent ionic bonding and electron transfer. So I'm going to go over a couple of examples and then I'll discuss each one in turn. Excuse me. So the first one is potassium chloride, and so this is the formula for potassium chloride. It's an ionic compound, and so we can explain why it is that potassium and chlorine react to form this compound using Lewis structures, and we'll also use the electron configuration to discuss a couple of things as well. Sorry about that. So we're looking, we need to be able to draw the Lewis symbols for each of these elements. And so you have potassium, and potassium is in group 1. So it's only going to have one valence electron, so we're just going to have a dot. So one dot. Again, you can put this dot anywhere, so I'm going to put it there. And chlorine is in group 7, so it's going to have 7 valence electrons, and so those electrons are going to be 7 dots. And so we have chlorine, and we'll do it like this, where I will start here. So I have 1, 2, 3. Okay, let's do it. Which way do I want to do it? We'll do it this way. So we'll do it here. So I have 1, 2, 3, 4, 5, 6, 7. Okay, so this is the Lewis symbol for chlorine. This is the Lewis symbol for potassium. And so you can see that chlorine has 7 valence electrons, so it wants one more to have a full outward shell. Again, we're following the octet rule, where the outside shell, the number of valence electrons for stability is 8. Except there's also the exception of hydrogen and helium and lithium. And so those elements that want to be like helium, they're going to follow the duet rule, because that first energy shell only has 2 electrons maximum. And so that first energy level only has one sublevel, which is the s sublevel, and that only has one orbital. So that orbital can only hold 2 electrons. So that's the duet rule. But for all other elements, it's going to be the octet rule. So chlorine would love to have one more electron to get that 8. And potassium would love to get rid of that electron, because then it will lose that valence electron, and the next shell will be full. So if I write this as a electron configuration, so it would be 1, S2, 2s2, 2p6, and then you have 3s1. That would be potassium. And so with, actually I forgot, that would be 3s2, 3p6, and it would be 4s1, because potassium is in the fourth period on the periodic table. So it's and one of the I'll talk about this now, is one of the ways in which you can identify an element is by the last part of the electron configuration. So here, the last part is a 4, so that tells me that this element is in the 4th period. It's in the S block, and it's in the first group of that S block. So all I need to do is go to my periodic table, look for the period 4, go to the S block, and go to the first column in the S block, and that will be my element, potassium. Okay. All right, so So this is the electron configuration for potassium. This is the valence electron, the one valence electron that I want to lose is here. If I lose it, then look what happens. So I get K plus, which is the positive ion, that's going to be 1s2, 2s2, 2p6, 3s2, 3p, and then that's it. So we lost this part, and notice that this part here is the next shell, number 3. And you'll notice, oops, I forgot this 6 here. So you'll notice here that we have 2 and 6, that's 8. So that's the octet rule, that's a full shell. So this is stable like the noble gases. And so if we look at our Lewis symbols, we can see that this potassium wants to lose the electron. This chlorine wants to gain the electron to get that full octet. So then this electron will be transferred to the chlorine. And then the way you write this is that you're going to have what's left over is K plus. So that would be the Lewis symbol for the ion K plus. Okay, we don't have any dots around it. And then for this one, chlorine now will have a full octet with a pair of electrons on each side of the symbol. And now that it has an extra electron, it's now going to have a negative charge. And so the way we do that is we put brackets around the Lewis symbol, and we put the negative charge on the outside. So this is going to be the way that you're going to draw the Lewis symbols for negative ions, for the anions. So we don't have square brackets for the positive ions, we just have the positive charge like we normally would write the ion, or the symbol of the ion. But for the Lewis symbol, you're going to have a full octet. You have your dots around there, around the symbol, and then you have the charge on the outside of the 2 brackets. So then, when you write this together, since we have plus and minus, that's going to balance out. So we just need potassium, and then we have the chlorine with the square brackets. So this would be the Lewis dot structure of your potassium chloride. Okay, so what about like something like sodium sulfide? So here's the formula for sodium sulfide. So we can write this in Lewis dot structures, and we can explain it according to Lewis dot symbols. So if I write the Lewis dot symbol for sodium, again, sodium is in group 1, so it's going to have 1 valence electron. So there's the dot for that 1 valence electron. And then we're going to have sulfur. So sulfur is in group 6, so it's going to have 6 valence electrons, so we're going to put 6 dots. So we're going to start here, 1, 2, 3, 4, 5, 6. So you can see that sulfur has 2 unpaired electrons. Those unpaired electrons would like to be paired because sulfur would like to be a noble gas, and so it needs 2 more electrons to have the full octet. Sodium, being the metal that it is highly reactive because it wants to get rid of that 1 valence electron. So it will react with sulfur. Sulfur wants the electron, sodium will give it. So we can transfer this electron to the sulfur, right? So now sodium will be happy with its octet. But then sodium will be happy with its octet. Sulfur is not happy yet. because it's going to have a paired electron here, but it still has an unpaired electron, so it wants one more electron. So where is that electron going to come from? Well, you have to keep in mind that there's a whole lot more than just one sulfur and one sodium atom in a substance. There's going to be hundreds of thousands of millions or billions of these atoms in a substance. So you've got another sodium atom somewhere around here. So that sodium atom wants to give away its electron. So that is going to then transfer its electron to this sulfur atom. This will become a positive ion. And now that the two electrons are paired, now we have sulfur is happy with its octet. So the way we're going to write this is we have Na plus, and we have another Na plus, and we have sodium. So again, sodium is going to have a full octet. 1, 2, 3, 4, 5, 6, 7, 8. And because it gained 2 electrons, it's going to be negative. So we're going to have square brackets, and we're going to have the 2 negative charge on the outside. So the 2 negative charge is on the outside, and so this is the way we draw our Lewis symbol for sulfur. So now we have 2 positive charges, we have a 2 negative, that's going to balance out the charge. So then our formula for our Lewis structure would be, we have 2 Na plus, and then we have our sulfur with its octet of electrons, and you have the 2 minus. So this would be our Lewis dot structure for sodium sulfide. And so this is how you can use the Lewis symbols to represent and explain why it is that you get these sorts of formulas from the atoms. And you can show the transfer of electrons using the symbols, and you can explain how it is that you get 2 electrons from the 2 here to fill up the octet. So, and then you get that balanced charge. So the Lewis symbols are really good in showing how the electrons are transferred and how it's making everyone happy with a full octet and getting that stability that the noble gases have. Okay, so that's it for this video. I hope you enjoyed it. If you like this video, like it, share it with your friends. Hit the notification button so you can be notified for any other videos I put out. Hit the subscribe button so you can subscribe to my channel, and put a comment in the comment section and let me know what you think and if you have any questions you would like me to answer in future videos. Thank you very much, and I'll see you next time.